Hi, I'm Benny D, and in this video we're going to look at transformations of power functions with a positive integer index. Okay, these are pretty straightforward, very similar to other functions. Okay, best shown with a couple of examples. Okay, so we need to sketch y equals x take 2 cubed plus 1. Okay, so remember when we're in this form, what we're getting is either when we've got odd power, something that goes like this. Okay, and it could be anywhere. Our usual one, remember, goes to the origin, but it could be over here, okay, wherever. The thing to remember when you're drawing it, okay, is that we actually have a point, okay, where the gradient is 0. This point there, our point of inflection. It's called for our odd powers, okay, and for our even powers, remember, our basic one looks like a quadratic. Remember, higher powers just flatten the bottom of this curve. Okay, but we also have this point where our gradient is 0 as well at our turning point. Okay, so it's just that important point, as I call it, okay, is a point that we need to track when we're doing these transformations. Okay, so initially our important point is at the origin. For this one, we can see it's moved to the right by 2 units. Okay, so it's going to go there, and then it's moved up by 1. Okay, so it's that's going to be our important point. Now, right at this second, we don't know whether we're going to come through something like this, oops, something like that, and have a negative x-intercept, a positive y-intercept, or it could come down a bit quicker than that. Okay, and it could come through as a negative y-intercept, a positive x-intercept, and then through, or it could of course just come through the origin. Okay, to know exactly what's going to happen there, we actually need to find our intercepts. Okay, so we're going to find our y-intercept. Okay, remember we let x equal 0, so we say y equals negative 2 cubed plus 1. Well, y equals negative 2 cubed is negative 8, plus 1 is negative 7. So our y-intercept is going to be negative 7. Remembering that this is 2 and 1, so we know we're going through there. So it's negative 7, so we know we're going to do something like this, coming down, okay, and coming up. That's reasonably poorly drawn there. Coming down and through. So we know we're going to have a y-intercept there that's going to be at the point 0, negative 7. Okay, and our x-intercept, we need to let y equal 0, so we're going to say 0 equals x take 2 cubed plus 1. Okay, take 1 away. X take 1 cubed, x take 2 cubed. We need to take the cube root of negative 1, which is negative 1 equals x take 2. Okay, add on 2, we're going to get 1. So x is going to be 1. So our x-intercept here, okay, that's going to have the coordinates of 1, 0. Right, and our coordinates at that point there, as we said, is 2, 1. Okay, and we're taking care of our translations. Okay, no dilations or reflections on this one, and we've labelled our intercepts, so we are all good with that one. Just going to make some room here. Okay, for this one, we've got a little bit more going on because we've got a dilation factor in there. So again, we need some axes. Okay, so let's look at that important point. Usually at that point of inflection, it's usually here. We're plus 1, so we're going to move it 1 to the left. And plus 2 means we're coming up by 2. Okay, so we know that is 2, this is 1. It's a positive cubic. Okay, so it's going to be shaped like this. Maybe coming up, maybe coming through. Okay, something like that. Okay, we're going to find our intercepts. Okay, we need those anyway, and it's going to take care of our dilation factor. So again, okay, find our y-intercept, let x equals 0. So y equals 2 times 1 cubed plus 2. Y equals 2 plus 2 is 4. Okay, so our y-intercept, my scale is a bit out here, it's going to be 0, 4. X-intercept, let y equal 0. 0 equals 2, so that x plus 1 cubed plus 2. Okay, I can divide by 2 from the word go. Okay, 0 equals x plus 1 cubed plus 1. Take my 1 away, equals x plus 1 cubed. Okay, I'm going to take the cube root of negative 1 is negative 1 equals x plus 1. I'm going to take my 1 away, so I'm going to get x equals negative 2. Sorry, this should be a negative 1 there. So this is going to have an x-intercept of negative 2, 0. Okay, so I've got my location of my point of inflection, I've got my y-intercept, I've got my x-intercept, so I've also taken care of this dilation factor as well. Okay, there's one more type of question that we can have here, where we're given a general form of our equation, so y equals y equals a outside of x, take h to the power 4 plus k, has a turning point at 2, 2 and passes to the point 0, 4. Find a, h and k. Okay, so what we do is we need to think about the knowledge that we have about our turning point in our function. Well, the point hk is our turning point, 2, 2. So we can simply put that in. So x take 2 to the 4 plus 2. So remember, our sign always changes, and that's why it's x take h in here, where h is our value of our turning point. So if it's take 2, our turning point is going to be at positive 2, 2. So that takes care of that. But we need this value of a. Well, that's okay. We've got one more bit of information here, which is the point 0, 4. All we need to do is sub in those values into our equation. We're going to be able to find our value of a. So you get 4 equals a. X has to be 0. So take 2 to the power 4 plus 2. Well, if I take my 2 away, I'm going to get 2 equals a outside of negative 2 to the power 4. Okay. Well, 2 to the power 4, negative 2 to the power 4, sorry, is positive 16. Get 16 times a, divide by 16, I'm going to get a equals 1 on 8. Okay, so my values of a, 1 on 8, h, 2, k, 2. Right, so that's our general process. Okay, they could have said, instead of saying the turning point, okay, the other thing they could have done is given us like multiple bits of information. So they could have said we are going through the point 0, 4. We could have said we go through, I don't know, 0.15, 3, 6, something like that. What we would have had to do in one of those cases is sub in all 3 of those pairs of values, and we would end up with 3 equations with 3 unknowns and solve them simultaneously. Most of the time though, questions around this are going to be drawing on your knowledge of the shape of this function and the fact that it has a turning point and what part of this function actually represents the turning point. Okay, so you won't need to do so much. You can simply, pull out values of h and k straight away. Okay, use your other information to find your value of a. Okay, so hopefully that'll be enough to get you through some of the questions on this section.